control settings page is where you define how the EMS interacts with each power source and breaker on your site. Each section represents a specific control functionality that can be configured based on your system architecture. Please note that settings can only be changed when the EMS is stopped. The Grid Control tab defines how the EMS interacts with the public grid. It manages active power import and export limits, applies peak shaving logic, and coordinates reactive power regulation at the point of common coupling, or PCC. This section allows you to define an import or export limit at the PCC. A positive value defines a minimum import, meaning the site will always draw at least this amount of power from the grid. A negative value defines a maximum export, which limits the power that can be injected into the grid, useful for sites under feed-in restrictions. You can also select how the EMS calculates total power, either as the sum of all phases or 3 times the lowest phase, depending on utility metering rules. The peak shaving function allows the EMS to reduce the site's grid import during high demand periods by using local energy sources, such as the BESS, gensets, or any other configured assets. You can activate peak shaving with BESS to discharge stored energy when the grid import exceeds the defined target, or enable peak shaving with gensets to increase production and compensate for the demand. The peak shaving target defines the import limit for each day group, allowing you to tailor operation to tariff periods or business schedules. The sensing method determines how total grid power is calculated, either as the sum of all phases or 3 times the highest phase, depending on utility metering standards. To ensure continuity, you can also allow gensets as backup for peak shaving. This keeps the site stable even when the BESS SOC drops below its minimum threshold. Finally, the SOC reserve option preserves a small portion of battery capacity exclusively for peak shaving events, ensuring energy is always available to flatten grid peaks when needed. On this section, reactive power control is currently disabled. When it's off, the EMS does not send any reactive power commands to regulated assets. Once we enable reactive power control, the system requires at least one controlled unit to be selected. That's why we see a warning: no unit is configured yet. First, we activate the PV unit. This unlocks PV-specific settings, including the maximum absolute reactive power set point. This value limits how much reactive power the PV inverter is allowed to inject or absorb. The first strategy is power factor range. Instead of forcing one fixed value, the EMS keeps the PCC power factor within an allowed window. Here, we define a minimum capacitive power factor and a minimum inductive power factor. As long as the measured power factor stays inside this range, the EMS won't overreact. If it goes outside the limits, the EMS uses reactive power to bring it back into the acceptable zone. The second strategy is power factor target. In this mode, the EMS continuously adjusts reactive power to keep the site power factor at the PCC equal to a fixed target value. You only define 2 things: the target power factor value and whether it is inductive or capacitive. The third strategy is Q equals F of U, meaning reactive power as a function of voltage. In this mode, the EMS reacts to grid voltage deviations at the PCC. When voltage drops below a defined threshold, the EMS can request capacitive reactive power support. When voltage rises above a threshold, it can request inductive reactive power to help reduce the voltage. You can also limit the maximum inductive and capacitive reactive power and define the voltage variation points that shape the response curve. Now, we also enable the BESS as a controlled unit. This allows the battery system to participate in reactive power control, just like PV. Each controlled unit can have its own reactive power limit to stay within equipment capability. When multiple units are enabled, we must choose the leading control unit. The leading unit is used first to cover the reactive power demand up to its limit. Only when it reaches its limit does the second unit start contributing. Here, we switch the leading unit from PV to BESS. No matter if PV or BESS is selected as the leading unit, the same 3 strategy options are available: power factor range, power factor target, and Q equals F of U. This makes it easy to choose the logic that best matches the grid code requirements and the site behavior. With these settings, you can precisely control reactive power at the PCC while leveraging PV and BESS capabilities efficiently. That's how you configure grid control in ECOM to manage import and export flows with maximum efficiency. In the next episode, we'll explore battery control, configuring BESS operation and energy optimization to see how the EMS manages energy storage for smarter site performance.